In games like cricket, you may have observed the ball deviate from its normal path when it spins. You may also have seen aeroplanes take off high into the sky. Such deviations in the path of the objects occur due to a phenomenon called the dynamic lift. Dynamic lift is an upward force that a body experiences due to a pressure difference between its upper and lower surfaces while moving through a fluid in motion. Dynamic lift is a corollary of the famous Bernoulli's principle established by Daniel Bernoulli in 1738. It states that if the velocity of a body moving through a horizontal fluid in motion decreases, the pressure applied on it increases, and to understand the dynamic lift, let us take the case of the wing of an aeroplane, which is a typical example of an aerofoil. The aerofoils have a characteristic shape that is more curved on the upper than the lower surface. When an aerofoil is made to move through air, the surrounding air streamlines to follow a curved and longer path on the upper surface of the aerofoil than the lower surface. This curvature of the upper surface results in a comparable increase in the velocity of air and a resultant reduction in pressure there. This also creates a net upward pressure difference between the two surfaces. This pressure difference gives an upward dynamic lift to the aerofoil. A similar upward force on the wings of an aeroplane balances its weight and gives it an upward dynamic lift for takeoff. Next, let us check out the case of a non-spinning ball that moves through air in motion. The streamline or the airflow path when the ball does not spin is very symmetric. As a result, the velocity of the air at all symmetrical points above and below the ball remains unchanged. With velocity being the same, the air pressure on the ball also remains the same. It does not exert any force on the ball. Hence, the ball does not deviate from its parabolic path. On the contrary, when the ball spins while moving through air in motion, it drags the air around it. If the ball's spin and its motion are in the same direction, the air above it moves in a direction opposite to it, reducing the velocity of the ball and vice versa. The change in velocity causes the air pressure to increase above the ball and to decrease below it. Thus, the streamlines above the ball become narrower than the ones below the ball. The difference in pressure that air exerts above and below the ball causes the ball to change its trajectory. In this module, you have learned dynamic lift is the lifting force due to the pressure difference between the upper and the lower surfaces of a body when it is moving through a fluid in motion. The cross-sections of wings of an aeroplane are like an aerofoil whose upper surface is more curved than the lower one. The pressure difference between the surfaces of an aerofoil gives it an upward dynamic lift. The pressure difference on the upper and lower side of the wings of an aeroplane gives it an upward dynamic lift. A ball without a spin will move along a parabolic path because there is no air pressure difference above and below the ball. A spinning ball would deviate from the parabolic path because there exerts a pressure difference above and below the spinning ball.